Okay, now we're doing number 9 from your Chapter 13 Equilibrium packet, still guest starring AP Chem G. Okay, so now we're doing a more serious ice table. This is going to be more like the ice tables that you're going to see over and over again until March. Okay, so let's write our balanced equation. Carbon monoxide reacts with steam to produce carbon dioxide and hydrogen gas. And this has a KEQ of 5.10. I'm just going to make it in red because I have to squeeze it in. Okay, so we know KEQ for this. We're going to calculate the equilibrium concentrations if we have 1 mole of each in 1 liter. So that means the initial concentrations are all 1. It is. It doesn't look like it is, but it's balanced. Okay, so all 1 concentrations. This is why we do Q most of the time. Okay, so before we do our ice table, we should find the value of Q and compare it to KEQ. So we know, are we going to make products or are we going to make reactants? This one's an easy Q because it's 1 times 1 divided by 1 times 1. So Q equals 1. So Q is less than KEQ, right? So we want Q to get bigger, so we want more on the top of the fraction, right? So we want more products. So that means in our ice table, we're going to put pluses by the products and minus by the reactants. That's the purpose of Q. Yeah. And we don't know how much we're making now. So they're going to be X's. Everything is 1 to 1 to 1 to 1. So everything just gets an X. If I had an imaginary 2 here, right, it would be 2X. Okay? So then 1 minus X, 1 minus X, 1 plus X, sorry. There we go. So now we can solve for X. KEQ equals 5.10. I'll color code because I can. Products, right? They're the same. So I'm just going to square it because we're going to have 1 plus X times 1 plus X. And then reactants on the bottom. I'm going to square that too because it'd be 1 minus X times 1 minus X. Now you have 2 options. Solver on your calculator, or in most cases you can do algebra. So for this one we can take the square root of both sides and you get that into a solvable form. There are occasionally ones that require quadratics. Does anyone not have a solver? Awesome. Let's just all use solvers. Okay. So plug this into your solver. Find X. You get 2 answers. Often one of them is incorrect. And by often, I mean all the time. So find the values of X. I don't even write them down. I just look on my calculator. Hold on. Yeah, what did you get for X? Why can't it be 2.5? Right, because then if it was 2.5, 1 minus 2.5 would be a negative concentration. Okay? No? Won't what be squared? No, you're okay? Okay. So I got this, 0.386. Is that what you got, Udaya? Okay. We're not quite done. So usually you're done when you solve for x, but not in equilibrium. So we have to find the concentrations. So CO2 and H2O. No, CO and H2O. Yeah. So we have to do 1 minus 0.386. That's 0.614 molar. And then CO2 and H2 are 1 plus X, right? Why am I doing that on my calculator? Yay! Right? It's glorious. Okay, thank you AP Chem G for helping Rob and Sarah.